Hi, I'm Ryan from Buster Beagle 3D. Today I'm going to show you how to make this injection molding machine. This will work with aluminum molds made from milling or hobby CNC machines, handmade resin molds, and even SLA 3D printed molds. Now, there are machines on the market right now that can do the same thing as this machine, and I'll put a link in the description to those. There's also a wealth of information on those sites about materials and tips and tricks of injection molding. They seem like very nice and sturdy machines, but as they range from just under $2,000 to about $5,000, I felt like they were a little bit cost prohibitive and out of the range of the average maker. I will show you how to make this machine for around $200 or less using these parts and putting it together yourself. Now let's get started. So the first thing that you're going to want to purchase is this drill press stand. You're actually going to want to buy two of them. And the reason we buy two of them is we are going to reuse one of these parts to hold the heat chamber on the bottom. Now, the way that this machine currently works is when you pull down on the handle, you're able to pull down to exactly 60 millimeters. So with the current heat chamber, if you were to pull down 60 millimeters, you would get roughly an object the size of 1 cubic inch. But the way that this heat chamber was designed, instead of having 60 millimeters, it actually has 76 millimeters. So if you're able to somehow get this machine to go down 76 millimeters, you increase the volume of your pull by about a third. So you would have 1.33 cubic inches instead of 1 cubic inch. Now, there are ways to actually extend this using some of the parts that you'll get with the other machine. So the first thing that you'll notice is you have this pin. So this pin is actually stopping this from going any further, and it's keeping it from pushing down too far. The other thing that you'll notice on the other side is we have this little bracket here. Now that bracket is also, it's what actually pushes down on the machine. Now, if you remove the pin and you keep the bracket the same way it is, you kind of run the risk of actually pulling down too far. And if you pull down too far and this bracket turns the other way, it's going to snap really hard. That spring that's inside of here is going to bust your knuckles. So you don't want to do that. But there is a way to actually fix that with the parts that you already have. So if you were to see the bracket that's on there, it's just this little bracket. It's got a larger hole on one side and the smaller on the other. But when you buy the other machine, what you end up with is another handle. So now this handle, if you notice on here, has the larger hole and the smaller hole. But this section is about 10 millimeters wider from the large hole to the small hole. So all I did was I took the handle from the one that I wasn't using it anymore, and I actually just took a hacksaw and I cut off the end, and then I had to drill the hole out just ever so slightly larger so that it would fit with the other one. So now if you see both of these together, you'll see that this one is slightly longer than the other. And actually, when you do that combined with removing the pin, you're able to get around the 76 millimeters per pull. Now, if you've removed this pin, you still have to replace it with something. But you can take a 3/8 bolt, the same type that you're going to be using for the plunger, and replace it. You want to put that there because you want to make sure that as you pull down, your whole machine is still aligned. So don't just remove the pin itself. You want to put something back in its place. Now, when we have the other machine, we're going to have this other part that we're going to have to take all the parts off of to use on the bottom. The first thing that we're going to do is remove the ruler and that bolt. So I'm going to take those things out. There's the screws inside of here. We can remove those. The whole case comes off. And then inside of there, you're going to see that pin that you needed to remove the clip on to be able to get it off, and the spring. So once that clip on the bottom has been removed, this whole pin can just come completely out. And then you carefully want to also take off this spring, and then this entire part on the top will come off. So what you're left with after everything comes out is the other part that we're going to need to hold the heat chamber. So this is going to be placed on the bottom like this, and it'll go on before we put on the top. So we'll do that right now. Now, if you notice on the inside of this hole, there's a nut, but you don't want to remove that because it's going to be used to attach the PID controller to the outside. So make sure when you open this up that you do not remove the nut from the screw that you removed earlier. So there you have it. Now we have the structural frame that everything is going to sit on. It's the part that's going to hold the plunger at the top and the heater base at the bottom. So the next thing that we want to do is add our custom stainless steel components. So the first one that we want to add is this little top hat piece, and this is what the plunger is actually going to screw into. So if you see, there's the thicker lip at the bottom, and you want to make sure that that stays at the bottom. So it's going to be inserted from the bottom in the top holder. And the reason for that is when this is pushed down, we want to make sure that this can never slip and applies the most pressure facing down. So we're going to put that in there, and we are going to tighten it. Now you want to make sure that this is pretty tight. You don't want this to slip out, and it's fairly heavy. The next thing that we're going to do is we are going to take our 3/8 bolt with a full thread on it, and we're going to add that in from the top. So I will add this in. One thing that's going to make this a lot easier, and I'll put a link in the Thingiverse files, is a 3D printed cap that you can put on the top to help you screw this in and out. Now, this particular one was actually made from this machine. So I created a mold in aluminum, and then I shot this out of plastic pellets. So this is actually a part that was made using this very machine. So I'll put that on. So the next thing that we're going to add is the actual plunger itself. So this is another one of those custom stainless steel parts. And as you can see, it has a little set screw in it. So what we're going to do is we're going to actually screw it onto the bottom of this 3/8 bolt, and then we're going to screw in the set screw to make sure that it won't move. Okay, so now this is the plunger assembly. So what you're going to do when you actually use it is you want to make sure that the bottom of this is already kind of almost in the chamber before you do your first pull, because remember, you only have around 76 millimeters worth of pull in there. So if this is raised above when you actually do your pull, that counts towards your pull. So you really want to turn this until it's right down above the chamber where you're going to actually do your pull, so that you get as much of the downward distance as possible. The next thing that we're going to do is we're going to actually add in the heat chamber itself. So here is the heat chamber, and that's just going to go in there. And so now that that's in there, we're going to tighten this. Now there's already a bolt that comes with this, but I like to take this 1/4 20 and it's about 4 inches long. And what I'll do is I'll place that in there, and then I'll screw that down. And the reason that I do this is because when I'm working with the machine, I want to be able to give myself a handle so I'm not ever touching anything that's too hot. So I'll put a 4-inch screw that goes through the whole thing, and then I have these little knobs that have a little nut on the inside. And I'll link a description on how to make your own 3D printed one on Thingiverse, so that you can use your same one, or you can buy these. They're really cheap. You can buy them at any hardware store. And then I'll put that on the end, and then this will be my little handle. So after I do a pull and I want to take it off of the mold, I'll just lift it up by this and then move it off to the side. One important thing to note at this point is this heat chamber is very, very heavy. Actually, anytime you're using this machine, you want to make sure that this is tied down or clamped to a table of some sort. You never want to use this machine without actually having it tied down to a table, because it could be very dangerous. And as you can see, if you put too much weight out to the side, this thing could very, very easily tip over. So the first thing that you're going to want to do before you actually get into the electrical is you're going to actually want to build the housing that's going to house all of the electrical pieces. So if you head over to Thingiverse, I have all of them listed there. And the first one that you're going to want is the actual housing for the temperature controller. And this is a part that will print without any supports. It will attach to the side of the machine. It'll hold the temperature controller, it'll hold the solid state relay, and a lot of the wiring that we're going to use. So I don't add this to the machine until later, because it's a lot easier to do the wiring with this not attached. But it is going to attach with some screws right to the side over here. And so now I'll show you how we actually do the electrical. So in the files you will find two different PDFs. The first one is this wiring diagram, and this kind of shows you where all of the wires connect and what everything is connected to between the AC power, the controller, the solid state relay, and the heater bands. And it's a good reference just to show you how everything is connected. I like to use this one as well. This one kind of goes over the different connections between the PID, the AC switch, and the solid state relay. And this one is labeled. It also gives you the lengths of the wires and whether I put a kink in the connections or anything like that when I was putting the wires together. This is going to be the one that I'm going to be using to show you where everything goes. The next thing you're going to want is this Rex C100 PID temperature controller, and then we need our 3D printed part for it to go in. Now what you really want to do is you want to connect all of the wires to the PID controller before you stick it in this case. And it's because this case is a little hard to screw everything into once it's already there. So you really want to be sure to put everything on first. Now if you look at the back of this, you'll notice that this has a few differences maybe from the one that you have. Some of these have all the screws, some of them just have these, but these are the only ones that you actually need. There's a diagram here that shows you where all of the connections are, and if you look at the top two, that would be 1 and 2, which is for your AC. We also have 4 and 5, which are for this solid state relay. It's what everything's going to connect to for that. The other ones that we need are 9 and 10, which are the temperature sensor. So I'm going to line all of my cords up against this so that I know which one that I'm actually going to be connecting to the PID controller. Now the other thing that we're going to need is this AC switch. Now this AC switch comes wired or not wired. It really depends on where you bought it. So I'm going to align all the wires to my diagram so I see where everything goes. Now I'm going to start with PID 1. So we can see here, this is the PID 1 connection that also connects to AC4 and solid state relay 2. Now I'm going to unscrew PID 1. When I attach these wires, I actually like to attach them from the inside and not from the outside. So what I mean by that is like this, where the wires is on the inside and not on the outside, just so that it doesn't kind of scrape against the enclosure when I have to push it in. So I like to have all of the wires and all the connections kind of facing in towards the middle. This is much easier to do when it's not inside of that enclosure. Okay, there we have PID 1, which goes to AC4 and solid state relay 2. The next wire that I'm going to use is PID 2, which goes to AC2. And the longer wire goes out of the enclosure hole to the heater. I'm going to connect PID 2 with the wires facing inwards instead of outwards where it would scrape up against the enclosure. This just makes it easier. Okay, there we have it. Next for 4, I am adding the wire for PID 4 that goes to solid state relay 3. Going down the list. Now I'm connecting PID 5, which will go to solid state relay 4. Okay. Now what we have left are actually the temperature sensors. Now before you actually connect the temperature sensors, I actually like to put that through the frame that we have the heat chamber on. So if you see here on the frame, you'll see a little hole on the side, and I actually like to route all my wires through that hole just to make it a little bit neater. It's not a necessary step, but it's something that I like to do. But to be able to do that, you actually have to put it through that first, because this end will never fit through. So I'll show you how I do that now. So I'm going to take the prongs and put them through the frame first. See, I took the prongs and put them through those holes first, and now I'm going to stick them through the hole on the bottom of the enclosure, because that's how the wires are actually going to be routed. So we're going to put them through the hole, then we're going to actually pull it out the front of the enclosure. So it's going to go through the hole in the frame, through the hole on the bottom, out the front, and then it can connect to the PID controller. And it really doesn't matter which way these are connected. It'll work either way when it's connected to 9 and 10. I'm going to bend these the same way that I was bending the other connectors. Okay, everything is connected. The only other wire that you should have left is this wire that goes from the solid state relay to the heater. And we have another wire that is going to connect from the AC to the ground. Okay, now I'm ready to push this into the enclosure. Now you want to make sure you push it in the correct way. we're going to route all of the wires through. You want to make sure that you put it in right side up. You can read what is on the front. So this is the orientation that we want to put this in. This is right side up. So you want to make sure that everything is faced in the right direction. And we just give it a snug little push. Just make sure nothing is snagged. Push it in, and there we go. Make sure none of the wires are snagged. Once you push it in, you'll hear a little click, and you'll know that it's actually locked in. So we can take these longer wires, which are these black wires, and we can route them through the hole in the bottom, because these are going to go out to the heater bands. Now we're going to connect the solid state relay, and if you notice, these have numbers on them too. There's 1, 2, 4, and 3. So if we're looking at our guide, we can tell that PID 1 is going to go to solid state relay 2, and we're going to put that on afterwards. First, we actually want to put on solid state relay 4 and 3 because that's going to go into the machine. So if you're looking at the solid state relay, you'll notice we have 1 and 2, which is going to face out. We want the metal section faced up. There's a little lip here that you can actually rest that on. So the first one that we are connecting is PID 4 to solid state relay 3. Then we're going to connect PID 5 to solid state relay 4. And you want to do these first because they're going to go into the enclosure first. There we go. It just snaps in right there on that little lip at the top with the metal part faced up. Then you'll see that we had PID 1 that goes to solid state relay 2. So that's this red wire here with the little angle on it. So I'm going to connect that. And you'll notice that I bent this side just to give me more clearance on the back of this solid state relay. And now on solid state relay 1, we have a wire that goes straight from that to the heater. So I will connect that. And that wire will route through the hole on the bottom. Now I'm going to connect the ground to the AC. And this ground will connect to the frame. Now before I make the final connections, I 3D printed another piece that the AC power is actually going to fit into. So now I have placed the AC power into the 3D printed part. There should be 2 holes that correspond to the holes in the case so that it can actually be screwed down onto it. Now I need to connect AC2 and AC4. And then I'm going to route the ground cable through the hole on the bottom. So coming out of the bottom, we should have the 2 heater cables, the ground cable, and the temperature sensor. So I'm going to close this up. And you could just use 2 small screws to actually close this enclosure. You can use ones that came with the frame, or just use really small ones that you have. I'm just going to use some screws that I had lying around that will self-tap into the 3D printed part. And there we have it. Now I am ready to actually connect this to the frame. Now this ground wire is going to connect to the bolt underneath this enclosure. These are the 2 heater wires, and this is the temperature sensor. So now we're ready to connect the PID enclosure to the frame itself. there's going to be 2 points of connection. One is up here. Now there should already be a nut in there from when we took the bolt out previously, and then the bottom is going to connect to here. And since you had 2 kits, you should have another square nut that the bottom one can actually connect into. So if you look at the actual PID box, you'll see that there's a hole on one side and then the hole on the other side. Now, the whole reason that this hole is here on this side is to make it easier to screw into this top nut right here. So what you want to do is you want to take your Allen wrench and push it all the way through. And I like to put it out of this side first. And then what I'm going to do is put on my screw and then feed it back through the enclosure and then out that hole. And then that just makes it easier to connect onto the top here. So I'm going to screw that in. Okay. Now on the bottom here, we're going to have to take that square nut and push it up inside of the frame here. We're also going to use a bolt with a washer just to try to prevent from snapping the 3D printed part. And the last part is we're actually going to take the ground that came from the AC controller, and that's going to go underneath here and actually connect to that bolt. So let's do that right now. So I'm going to stick this in there. Sometimes it's easier to get it started before you actually put in the ground. So I'll put that up there. You can also stick the ground on the inside here if you like, if it's easier. There we go. Now we have the PID controller connected, and we can move on to the electrical at the bottom. Now we're going to add these heat bands to the heater chamber at the bottom. These are 35 by 35, 110 volt by 380 watts, and we're actually going to be able to fit 2 of these onto this heat chamber. Now, as you're going to see, the diameter of this is smaller than the diameter of the heat chamber itself, but that's okay because we actually have to extend these a little bit. So you want to make sure that the gap in these heater bands are actually at the same spot as these 2 threaded holes in the heat chamber. That's because we need to have access to those, so we need to add that gap in there. So the one on the top needs to actually have the wires facing up, and the one that's going to be placed on the bottom will have the wires facing down. And this is to give us some room when we actually want to add any type of heat wrap around the middle, just so that there's space and so that there's room to do so. So I'm going to make a little bit of extra room. Then I'm going to place the first heater band on with the wires in the up position. Now I'm going to place the outer clamp to tie it down. Again, being sure to leave the gap for the threaded hole in the center. Now this top threaded hole, the only reason this is there is to keep the entire heat chamber from being able to be pulled out of the top. So sometimes when you actually pull down the handle, there's a little bit of suction that's going to come back up from the melted plastic. And so what we have here is we've actually added a threaded hole so that we can add a 1/4 bolt. This will just thread right into there, and this is going to prevent this entire heat chamber from being pulled out of this bracket. The bottom hole is going to be used for the temperature sensor. Now I will place on the second heat band. this time with the wires in the downward position, again leaving a space for the hole in the center. Now before you actually put on the bracket that's going to tie down this heat band, you want to put on the heat sensor. And the reason for this is the way that the bracket is situated, it's going to almost touch the top of this nut. So you won't be able to screw it in if you've already tied down that heat band. And we just want to hand tighten this. If you'll notice, the actual metal on the heat sensor is pretty cheap. So if you were to really kind of tie this down with a wrench or pliers, you have a tendency to actually break it. So you kind of just want to hand tighten this. You don't want to apply too much force to it. And it's not going to go anywhere once we put on the heater bracket. So now I will add on the heater bracket and we'll tie this down. So as you can see, I've now run all of the wires through the bracket that's actually holding the heat chamber. And the way that these are actually going to be connected is we want to take the wires on the same side and actually connect them. So the wires on the top and bottom on the left side will go together, and then the wires on the top and bottom on the right side will go together. And what I like to use are these solder and seal connectors. They're just these little plastic pieces with solder in the middle, and I'll just put the two wires from the same side together on this, and then I will connect the black wire that goes to the PID case, and I'll stick that in there. And then I like to use a heat gun to kind of just melt that solder down. You can do this with a heat gun, you can do this with a lighter, but since I have a heat gun, I will go ahead and use a heat gun. So we'll heat that down. The thing I like about the solder and seal connectors is that they do a nice job of insulating the wires. You melt this middle piece enough and that solder infuses into all the wires. They're really great. So now I'm going to do the same thing to the other side. This is the top and the bottom of the right side of the heaters. I'm going to put it right in the middle where the solder connection is. Then I'm going to place my other wire down until it meets where the solder connection is. Then I'll use my heat gun to melt that down. You can see the solder in the center liquefy, and once it does that, you know that it's good. So everything is now connected. The two heater wires and all of the heater band wires are now connected. I like to kind of finish it off with this 1/4 inch split loom. You don't actually have to do this. It's just kind of nice for wire management. This just opens up and you can put all the wires in and then take them all the way up to the case. So here you will see our finished machine. As you can see, I've added the wire management to the side just to kind of clean up those wires that are going to the heat chamber all the way up to the PID case. I've also added an extra handle onto the side that goes through the middle of the bracket that's holding the heat chamber. That makes it a little bit easier to kind of lift the entire heat chamber up and move it off to the side. I have also wrapped the heat chamber itself in a titanium exhaust wrap and then tied that down with some stainless steel ties. And I do this not so that I can touch it, but to keep any ambient heat from escaping those heater bands and not being used to heat the chamber itself. So I like to wrap that in anything. You can use exhaust wrap, you can use any type of insulation that you have, but really you just need to make sure that whatever you put up against it can withstand at least 400 degrees Celsius. And so our machine is now ready to test, and we're ready to see the parts that it can make. Okay, so now we're ready to test the injection molding machine. So the first thing that we're going to do is we're just going to flip the little switch on the back. That's going to turn on the machine. Now the number on the bottom is the number that you are setting the temperature to, and the number on the top is the current temperature. So to actually set the temperature, we want to hit set, and then press the arrow keys until we get to the desired temperature. So I'm going to go up to about 250 and then hit set again. Now let's see how long this actually takes to heat up. And while that's heating up, I'm going to start putting in some plastic pellets. Now these are just regular black polypropylethylene pellets. Now the other thing that we want to do when we're using an aluminum mold is we actually want to heat the mold slightly. So actually what I like to do is while the chamber is heating, I just stick my aluminum mold right on top. So that'll slightly heat the mold up and it'll make for a better pull. Now you want to do this in a well ventilated area. This machine is also tied down to this desk so it won't move. And so now we'll just wait for it to heat up to the 250 degrees Celsius. As it gets towards the end, it's going to slow down because the PID controller is starting to lower the temperature as it reaches that high so that it never kind of goes over it. So if you see around 246, 250, it's all about the same thing. So we can actually start with this. Now, if you see a little bit of smoke the first time you do this, that's completely normal. There might be a little bit of oil on the stainless steel parts from when they were manufactured, and that's just kind of burning off. Also, you might have a little bit of dust or any other kind of particulate on the plastic, and that's also burning off, so it's completely normal. Okay, so now I will take off this part. I'm going to use these C-clamps to clamp it together, keep it closed. So there we have it. Going to I'm going to lift up the machine, put the nozzle right on the opening, then I'm going to push down. Pull it off to the side. You'll see that there's actually plastic that's been shot into the mold. Open that up. Now be careful, this is very hot. And there it is. So on this particular one, I have to break it off with a screwdriver. And there it is. There's our part. So the mold is still hot. I will close this up. Put my clamps on. You can also get a clamp that is a kind of a fast clamp to put this on and off. Now there's still enough material in here, but I like to put the pellets in between shots as well, and this kind of makes sure that this melts by the time I need to do the next shot. Drop that down in there. Lift this up with one of those handles. Put it down. Line everything up. And shoot. There it is. There's the next one. chamber. Now this is a mold off of that site that I talked about in the beginning. So I'll show you how this one works. Drop that in there. Put my heat chamber on. Press down. Pull up. There you have it. So there you have it. Here is our fully complete injection molding machine. I would love to see in the comments if you created one and what you're making with it. Thanks again for watching, and I hope you guys enjoyed this.